Hello, friends. Welcome back to the next session. So, in the previous demo session, we were looking at concept of generative AI. We directly jumped into generative AI without wasting any time, and we looked at how we can apply generative AI applications. Today, we'll do another demo in which we are trying to see the end-to-end machine learning or AI life cycle. So I can say end-to-end AI life cycle. In this, we'll understand the entire breadth and spectrum of the AI life cycle. And most importantly, today what we'll also cover is where the jobs are. So there are different places, there are opportunities for us to, pitch ourselves, but everybody will come from different backgrounds. So today's session will clarify all those doubts that where the jobs are, how we need to prepare for those jobs, and what are those entry points for those different jobs. So for that, I'll start with a story. I'll take you back almost like 20-25 years back, and then imagine we are taking a business. Imagine I take a business of a bank. Imagine there is a bank called as ABC Bank in early 2000. Okay. ABC Bank. So this ABC Bank, if you see in early 2000 or even before that, the way you try to do banking is you go to a bank. It's a physical bank available. So you go to a bank, you do a deposit to the bank, you do a retrieval from the bank, you try to open a fixed deposit, you apply for a gold loan, you apply for a home loan, and so on. So all those transactions typically used to be handled by a cashier or a teller or a clerk. And those transactions typically used to be stored in a software terminology, they used to be stored in a database. So these databases, we used to call them as ODS, operational data stores. And a teller or a cashier are the one who are doing transactions. And these transactions are basically going and sitting into these ODS databases. ODSs means operational data stores. Now, what these operational data stores? The operational data stores store your transactions, when the transaction happened, what was the transaction, who did the transaction, all those information is stored. Every day there are transactions happening, so all that information is stored in this ODS databases. So back in those days, they employed a data analyst. The purpose of this data analyst is to try to query these ODS databases. You can run a SQL query. You can run a SQL query on these ODS databases and identify, like, for example, we have 200 branches. So out of these 200 branches, which branches are highly successful? The branches which are creating more revenue, the branches which are creating more cash flow, the branches which are not performing, right? And if I take a specific branch, which customers, what type of offers we need to offer to the customers, what type of transaction patterns happen. So all these big questions are there because you need to operate the bank. So C-level executives need to identify these patterns. What is the monthly average balance in a bank? If we know that information, then based on that information, you can move the cash. Probably you can give more loans, or you can move the cash around and ensure that the smooth operations uh, can happen. Maybe there is one location which is only saving. There's a lot of balance there, but they are not utilizing the balance. There is other location which is requesting for more loans, but there is no cash reserve. So people used to do this kind of analysis and try to understand how to do a best utilization. So for that, they have employed a data analyst who can do the SQL queries to understand the patterns of the data from the ODS, operational data stores. Now, the data analyst used to run the SQL queries during the day. At the same time, the teller is also doing some transactions. So teller is doing some transactions, maybe a deposit of a money, withdrawal of a money, and things like that. At the same time, the data analyst also is running some queries. So when the data analyst is running queries, it used to create a bottleneck on the operational data stores. The operational data stores used to have some kind of a bottleneck, and then because of the bottleneck, people decided that let us not run these SQL queries during the business hours. So imagine the business hours are from 9 o'clock to 5 o'clock. If these are the business hours, people decided that, okay, let us not run these jobs from 9 o'clock to 5 o'clock. Let us run nightly jobs. Now, the nightly jobs became very popular. Of course, nightly jobs are all also the same jobs, the same SQL jobs, but they used to run on the ODS, but not during the day, but in the night. Right? So they are running in the night. We are running these jobs in the night, and maybe after 5 o'clock, say 9 o'clock, there is a job running. There is a job running in the midnight. 12 o'clock, there is a job running. So these jobs are running in the night where there is no operational hours. People are not utilizing. The banks are kind of closed, and they were very successful because they are not hampering the experience of the users. So that worked really well. Till the time, there are two things happened. First one is the internet adoption, and then second one is geographical expansion. So two things happened around 2005 is the internet adoption and geographical expansion. Internet adoption, we know, like, okay, websites came, mobiles came, and everybody were doing banking. The banking was not confined to a location. So I can do banking from my mobile phone. I can log into a website and I can do a transfer. So that was one problem. The second problem was the companies also expanded to different geographies. So they are not confined to, say, US geography. They expanded to Australia, they expanded to Dubai, China, and different parts of the world. So when they expanded to the different parts of the world, there was no such lean period. We call it as a lean period, where I can say that, okay, this is the time the customers are not active, so I can run my jobs. So there was no such lean period in which we can run the jobs. So that happened, and because of which the new concept emerged, which is called as data warehousing. So we created something called as warehouses or data warehouses, DWH, data warehousing systems. Now, what this DWS does, they decouple the transaction data, the ODS data, which is the transaction data. They do something called as extract, transform, and load, ETL process, where they extract the data from the actual tables, do some transformation. Suppose we are loading the data from A table to B table. We don't need everything from the A table. We will just need few columns. We might need some aggregated information. So they do some transformations, and then and then finally load it into the warehousing tables. Now, warehousing tables are similar to the ODS tables, but warehousing tables are like decoupled. They are like the backup. Warehouse, as we say, it is like a backup of your actual data. Now, when you are backing it up, I can now run my nightly jobs on my warehousing tables instead of running on the ODS tables. So there was a connection cut from the actual tables. The jobs were no longer running on the actual tables. We were not running the queries on the actual tables. All those things were run on the warehousing tables. Now, the warehousing tables gave two great advantages. First one is it gave the ability to decouple the operational databases with respect to the warehousing databases. So there is a clear decoupling. We don't have any issues with any uh, issues with the systems getting overloaded and all that stuff. So we don't have any such kind of a problems. And the second one is the warehousing tables are also popular in storing historical data. Means I can store last year data, 5 years back data, and all that possibility was there. So that now once I store historical data, I can do historical comparisons also. I can compare this month's data with last year's data. I can compare this week's data with last month data. I can do that comparative analysis. I can see businesses, how they are performing over the time. All those things were possible. So this was running for quite a long time till the point where newer type of data sources started emerging. Around 2010, 2012, that was the time the concept of big data came into picture, where people started creating something called as data lakes. Now, what are data lakes? Data lakes are the solutions primarily which were built on Hadoop kind of sources. Hadoop and big data, this came into picture. So Hadoop, or you can also use some cloud providers like AWS. They have their managed service of Hadoop. We have like Azure, GCP. Thanks to the cloud computing, all these things were quite easily possible. So what this data lakes does is they don't just store structured data. Now, the data warehousing, while it was great solution, one problem was it was primarily focused on storing structured data. So this data is in a row column format, everything is properly organized and so on. It is a very structured data. But if I want to store unstructured data, maybe I want to store, images of checkbooks, maybe images of checks. I want to do a scan of certain documents. I want to store some videos. I want to store some sensor information. So imagine I want to store all those kind of data types, then structured tables were not really suited for them. That's when the unstructured data came into picture and we started creating data lakes. Now, the data lakes is basically, just a second. So the data lakes can store a lot of unstructured data. So I can store some videos. I can store some images. You see image. I can only draw one image. It will be two mountains, one sun, few birds, and a river. I hope you also draw similar type of image, right? So, so you can store images. Then what else? You can store documents. You could store some log data or a text data. This I can call text documents. You can store log information. Logs can be system logs, operational logs, all those log data. You can also store something like what else? You can also store some sensor informations like, for example, you have some IoT sensors, some documentation which is having structured, unstructured, semi-structured data. So all these formats of data is now possible to be stored in a central storages. Two purpose. First one is large volume storage is possible. And second one is now once I have that data available, I can use it for further processing, further analysis, and so on. Now this is one door for AI. The first door for AI is where we are doing this thing called as data engineering. I'm trying to squeeze it here. So this section is called as data engineering. So if you have any questions, please put in the chat window. I'll be able to see those questions and then answer them. So this section is the first door I talk about. It is called as the data engineering. The people who will be working are called as data engineers. They can be cloud data engineers, like they can be specialized in AWS, Azure, GCP, and so on. But the role and purpose of these people are they are having some kind of transformation background. They will do data munging, they will do data ingestion, data retrieval, data storages, computations. So all these skills are required. So they are responsible for loading the data from your source tables to the backend warehouse tables, do some transformations, do merging of tables, creating new records. They also do something called as feature engineering. I'll just talk about it in a minute. They also do feature engineering for creating multiple features and so on. So all these roles will be done by data engineers. First set of roles. After we do storage of the data, now we have all this raw data. The next step, which is very important, is to create something called as data visualization. So data visualization is trying to create some stories, trying to create some graphs, charts, dashboards using the available raw data. So we need to find out the patterns in the data. We can't directly go and jump and do AI on the data. You have to do some kind of pattern analysis. You need to understand, okay, there are 100 fields. Out of these 100 fields, which are the fields which are important for my analysis? Imagine I want to give loans. I want to predict whom should I give loan. For that, I might be talking to an account table. I might be talking to a sales table. I might be reading data from multiple tables, accounts table, product table, sales table, and so on. From all these different tables, every table is having like say 20, 30, 50, 100 features, 100 columns. Now, out of the 100 columns, which columns are important? Which columns are not important? How is the relation between the columns? Where are the clues? We need to understand all those things, and that can be understood by drawing some kind of charts and patterns and graphs. You can use tools like Tableau. We have ClickView. We can also write Python specific codes. We have libraries like Matplotlib, Pandas, all those things we will learn. But you can do use these libraries for doing data visualizations. And then once you do visualizations, you will be able to create patterns, graphs, charts, dashboards, and using that you can find out relations. And this jobs is done by somebody called as data visualization engineer. This is the second door. Data visualization engineer is the person who is responsible for using some of these tools, Tableaus, ClickViews, Python, and other things to kind of create charts, graphs, and reports, which will help us to draw some kind of patterns. Now, once I have drawn these charts and graphs, I understood some of the patterns. The next step is to create features out of it. Now, what are features? Features are nothing but reusable components which are used for the AI lifecycle. The process is called as feature engineering. In the feature engineering, of course, here also the data engineers are responsible. We will be doing some kind of transformations. The outputs of the feature engineering are called as features. So as an example, for example, we are collecting account data of our customers. Account data means, imagine I am a customer. I am using the bank transactions. I'm using the bank's account for doing a lot of things. In the morning, I'm drinking coffee. I go and have breakfast in a small tiffin center. Then after that, I go and fill fuel for my vehicle. Then I go to office. Afternoon, I'm having lunch. In the evening, I go to a mall and purchase some t-shirt. And then in the night, I watch a movie. After that, I do dinner and then come back home. Imagine this is my 1 day's transaction. So you see, every transaction is getting recorded. And in my account table, you have all the transactions. And generally for machine learning or data science, AI analysis, we don't need individual transactions. We need aggregated information. Maybe how much did Sitaram spend in a month? Average spending, something like average spending, total spending. So such kind of things. So we do create those aggregated outputs. Those aggregated outputs are called as features. So instead of like I take each and every transaction, maybe I'm drinking coffee 3 times a day. So I will spend 3 times. I might use an UPI, I might use a credit card, I might use another mechanism of paying. But you get the point that there will be three line items for the transactions. We don't need all the three line items. Maybe I need every day how much is the average spend, or maybe aggregated over a month, monthly average spend for the customer. So that is a feature. So we will construct the features, and those features will be used in our analysis rather than the raw information. So once we construct the features, the next central step is, is what we call as modeling. So if you are doing any course, a university course, an academia course, this is the step where you will have a great focus. So here you will be learning about supervised machine learning, supervised ML, unsupervised ML, right? We will be learning recently, there are something like generative AI, and also agentic AI. All these things we will be learning, and this is part of something called as modeling, where the central AI piece is involved, where we are trying to create some algorithms, where we are trying to create some models. Different patterns are there. If I just take supervised machine learning, within supervised machine learning, there are hundreds of algorithms. And unfortunately, many times we see that if you take any courses, if you take some academic sessions or anything, most of them focus on this section, the modeling section, where they'll talk about 100 different algorithms. You'll spend 3 months just learning algorithms. But what you're going to understand after end of the session is that modeling is one piece of the equation. It is one piece of the Lego block. It is very important, but it is one part of the equation. You need to know all entirety. You need to know all other things as well. You need to know how do you deploy this model, how do you deploy this model in a batch program, in a real-time program, how do you monitor this model, how do you identify guardrails, how do you create governance across it, and all that stuff. So all those things are very essential, but modeling is also important. So here is where you are learning about how to create different types of models, different algorithms, and so on. And this is the third door. People who are working here, again, there are two sets of job roles. We have data scientist and then AI engineer. These are the roles: data scientist and AI engineer. AI engineer is the person, this is like a recent role, where the person who is responsible for creating generative AI applications, person who is having an understanding of agents, agentic AI, and that process. That role we are calling as AI engineer or Gen AI engineer. So name changes a little bit, but I'm generalizing. That is the AI engineer role. And there is another role called as data scientist role. Data scientist is a person who who is using some of the algorithms for creating classical machine learning applications, maybe fraud detection, recommendation engines. You would like to identify anomalies. You would like to determine loan approval process. You would like to do a churn analysis. So all those things is done by data scientist. There is junior data scientist, senior data scientist, citizen data scientist. So likewise, different roles are there, but all these roles fall under the bucket of data scientist. This is another door. Say, okay, I got the algorithm, I understood the algorithm, we have created the model, but it is only beneficial when it is running in production, right? So the next step is doing something called as deployment. There is a next step called as deployment. And we are talking about deployments of both classical machine learning and newer AI techniques like generative AI, LLMs, and so on. In deployments, there are two deployment techniques, which are called as batch and online. Batch deployment means we are running jobs. So you will create a model. The output of your modeling is a model, which is like an executable. You can call it as a model. This model gets deployed either in a batch mode or a online mode. Batch mode means you're creating a batch job which is running at some frequency. Say like every day, 9 p.m., there is a job which is running, which collects the records of that day. And imagine I want to predict whether the customer loan should be approved or not. Okay, we're trying to do a loan prediction process. So every day we will collect all the customers who have applied for loan during the day, and in the night around 9 o'clock there will be a job running which will take all the applicants data, and then from the data it will try to predict how many are eligible for loan and how many are not eligible for loan. So it is doing a prediction process. Imagine you get 100 applicants. Out of the 100 applicants, you can say 82 applicants are approved and the other rest of the applicants are rejected. So that process run in a batch mode. You could run it in some kind of a cloud service, suppose an AWS cloud, where you could execute this model in a batch job. You will be using tools like Jenkins, Airflow, and so on. So for scheduling the job, running the job, and all doing all the things. And what this process does is it runs the job in a planned sequential fashion. Every day it will be scheduled, and the job will run and do the prediction and give the result. Maybe the job is running in a entire sequence in a pipeline. Maybe the first job which is doing predictions of who all are approved, rejected. Second job, there can be another job which is sending emails, or maybe another job which is constructing the content of the email. Maybe like you will get an email saying that congratulations, Sitaram, your loan is approved, right? So that is the downstream job. So you might be part of one pipeline where you are just doing your prediction, but those predictions are being used by another job for doing something else. So it is following a sequence. It can follow a sequence, it can follow a downstream, and that will solve the entire business problem. Maybe some jobs are sending emails, right? So they send emails to all the customers whose loans are approved and rejected, and so on. That is a batch process. Now, what is the online process? Online process is pretty straightforward. You might have a web application. Maybe you can log into a website or a mobile banking, right? Mobile banking application. where you will open up an application, you will fill all the details like your name, your marital status, your bank balance, your credit score, all those things. And then you click on a submit kind of a button. So you have a submit button. So when you say submit, there is a new page which opens up, which basically says congratulations, your loan is approved for so and so. And that is happening in a online mode or a REST mode. We call it as, we create REST APIs. So you have an API which is created, and this API will be invoked by the online mechanism, and the systems will also be interacting with this API for doing a real-time prediction. Now, this is not a batch prediction. It's not happening in a batch mode. All customers are not being predicted. This is one-on-one prediction. You log into the application, you fill all the details, you submit. In the real time, there is a call happens in the backend. It calls the model. So this also invokes the same model. The same prediction model will be invoked, and that model will do the prediction in real time. So this is a batch and online deployment methodology. So here, this process is called as ML ops when we talk about classical machine learning, and we can also call it as LLM ops for our generative AI based applications. And the people who are working in this particular area, they are called as ML engineers. So this is another door. This is another door for getting into the AI pathway. All right. So this is one more thing. And ML engineers also do something called as, there is another thing called as monitoring, which is linked with the deployment. It is called as monitoring. So what is monitoring? There are again two concepts. One is called as explainability. And there is something called as fairness. In fact, I'm doing doctorate on this. My doctorate thesis is on fairness, privacy, and ethics of generative AI applications in banking. So this is my doctoral thesis. And what this monitoring talks about is, okay, the model is already deployed. Imagine the model is deployed in this year, January. January, we deployed the model, and now it is November. Now I want to understand how this model is performing. Is it performing similar to the way it used to be performed before it is deployed? All the metrics are similar or not? Whether there is any deviance? Is there any change in data? It is called as data drift. Whether there is any change in data, or whether there is any decay in the performance of the model because of a lot of other parameters. So all those things have to be monitored. It's not like, okay, I deploy the model and I'm done with my work. We need to monitor the health of the model as and when it is progressing. So we construct something called as model monitoring jobs. What these jobs will do, they will compute a lot of parameters, a lot of performance metrics are there, a lot of drift metrics are there, fairness metrics, explainability metrics will be there, which will help us to identify the health of the system, the goodness of the model. Is it still continuing or is it decaying over the time? Because this model is in production, it is doing some real decisions. If the model is not performing to the best possible, you will have a lot of difficulties or problems, right? You don't want to get into that. There are concepts like explainability and fairness. We will discuss them in great detail. But what they talk about is that if you are doing some decision, explainability talks about if you are doing some decision, on what basis is the decision made? The model is saying that this person is approved for loan. On what basis are you saying that this person is approved for loan, right? We need to have some kind of metrics details in the background which quantifies our decision making. Fairness talks about irrespective of the, say, like demography, caste, creed, financial status or anything like that. Our model should be performing equally. There should not be any bias in the model. That's what the fairness talks about. And last but not the least, we have another component which is governance and quality. This one we call it as AI protocols. And governance and quality, these are very, very essential again. So quality talks about the testing part of it, right? How are these models tested? So we have roles like ML testers, MLTs, we call them as MLTs. These are SDETs who primarily wear the hat of a QA engineers, QA developers, and they will be testing the AI ML models to see how well the models are there. All sort of testings will be done. For example, we do penetration testing, we do ingestion testing, we do prompt analysis, prompt testing, uh, evaluation metrics will be there. We will try to analyze the load testing of the models will be there. All those things will be done by the quality engineers. Typically, this is another role. So here we have two roles. The governance piece will be taken care by the product manager or product owner, right? So this is one role, and business analyst, product manager, product owner, and the quality part will be taken care by ML testers, MLTs we call them, MLTs or QA engineers. Depending upon the company, there are multiple roles, but this is the set of roles which are linked here. So governance is like, okay, governance talks about the entire project analysis. Means if I'm doing an AI project, what is the ROI of the project? What data it is using? What are the security metrics which need to be followed? Is it following the right governance tracking or not? Is the ROI, are we achieving the ROI or not? ROI of doing this project. All those things will be managed by project owners, product owners, project managers. Again, roles change a little bit, but these are like the people who are running this entire project. Right? They will be having a bunch of machine learning engineers, they'll be having a bunch of AI engineers. All of them work together in tandem to see the success of the AI project. Or else what happens, technology is good. You can implement a new Gen AI tool, but unless until it is giving some business value, there is no point. And that's the reason you see that many AI projects do not go beyond the POC stage. You might have heard this many times. The reason is this. While AI is really good, there's a lot of traction, there's a lot of awareness is there, but unless until you use it in a right business process, you will never be able to get benefit out of it. Right? So we spent like 45 minutes now, and I am quite sure that this is overwhelming for you. But please bear with me. We are going to do a deep dive in most of these components. During our course, we will be going through different algorithms. We will be understanding different stages of the AI lifecycle in a great detail. But one thing which I want you guys to take away today is what are the different roles or the different doors to this AI lifecycle. For example, if I am a QA engineer, I might have experience, 10 years experience in QA. So I don't recommend people to directly jump into the AI or become an AI engineer. I would first urge them to identify, are there any QA related roles for AI? Of course, there are so many, and we need people who have that expertise, who know the understanding of AI and who can perform QA. They are called as machine learning testers, QA testers for AI, and these are the different roles. So imagine we do an entry point there. So entry point will be here. So once you do the entry point here, then eventually from there you can get into machine learning engineer role or a AI engineer role. Imagine I am a DevOps engineer. Imagine if you are a DevOps engineer, the best role will be machine learning engineer because this person is responsible for deploying the models into production. We know like how do you deploy, how do you do auto scaling, how do you create Docker containers, run Kubernetes, all those things which are very much familiar for a DevOps engineer. So somebody coming from a DevOps background, they want to do learning AI and all, don't directly get into AI engineer role or a data scientist role. Identify the ML engineer roles, which are very suitable. And then from there, they can slowly navigate into an AI engineer role. Somebody who is already a programmer, who is already hardcore developer, suppose they're doing Java development, full stack development, and all that stuff. For them, the good roles will be either AI engineer or a data scientist. These are the good roles. For somebody who is coming from an ETL background or a data engineering background, for them, the data engineering is the best entry point. Once they are familiar with the data engineering, they know like what type of transformations are done and all that stuff, they can eventually come to the central piece and become a data scientist or a AI engineer. Similarly, somebody who is having the visualization background, somebody who is a data analyst, for them, the data visualization engineer is the first entry point, and then eventually they can become a data scientist. Got it? So what we understood today is an end-to-end life cycle. If you have any questions, please put them in the chat window. I'm quite happy to answer them. All these sessions will be recorded every day. The sessions are being recorded. You will get recorded videos. Kindly give us a few days because the batch is getting formed. We will have few more people who will be joining. And then once everybody is available, we will create the batch and share the recordings. So if you are seeing that this entire stuff is up, multiple segments are there, right? So we have ML engineering is there. So these all things, ML engineering, anything related to that will fall under the engineering piece of it, where you would like to get into maybe infrastructure, setup of the clusters, setup of the platforms, creating auto scaling and all that stuff. So those all things, the engineering role will be there. AI engineer, data scientist will be software side, right? So that there is the difference. We can pursue both of them, and both of them can be pursued and can be used for our own purpose. And then eventually you will be able to uh, get into one of the other roles which you would like to uh, like. Excuse me. So there can be a question like about PMs and product owners, delivery managers, such kind of roles. There are roles which are there, but eventually, as we are seeing that those roles are getting shrinked. So I would recommend anybody who is like a pure play project manager, I would recommend them to uh, become a technical manager, like engineering manager, who is understanding the technology, who is understanding the uh, nuances of the technology and so on, and so that the role can sustain for a longer duration rather than just becoming a person manager, like people manager like that. A combination of roles. we call as TPOs in our organization. We call as TPOs, technical product owners. They are the people who are defining the business. They are people that are defining the these things and so on. And then that can be taken at a next level. So please post your questions in the chat window. I'll happy to answer them. I'm doing a dual PhD. One is I'm from Hyderabad, so I'm doing from Triple IT Hyderabad, one university. So there I'm doing a part-time PhD. And the second one, I'm doing a doctorate in business administration from Rushford Business School from Switzerland. So that's the dual PhD. So, okay, there's a question that uh, does the governance need to be established before deployment? Governance has to be there, um, has to be hand in hand, right? So hand in hand with AI. So it is has to be there from starting till ending. So it is not like an aftermath, not just at the deployment, at the creation of a project also, we need to have governance in place. What type of data are we trying to target? What type of model we are trying to create? What is the output of the model? So all those things are quite necessary. That's what the role of governance. It's not like an aftermath. uh, we create a project. I will talk about a project also. So we were in my company, we are running a project for almost like past 5 years. It is a end-to-end AI governance model. So right from the start of the project to the end of the project, even after the deployment, monitoring is also part of governance itself. Right? So what's your role? So see, I'm doing PhD for a certain target. So my target is different. I personally feel that uh, every one of us should have some kind of craziness, some level of craziness. I'm not sure if you're familiar with famous actor in South India, Pawan Kalyan. I'm his great fan. So he says we should have some kind of craziness, and that is really true. Every one of us should have some kind of craziness, and my craziness is this. So uh, it might be different for different people, but everyone should have that craziness. So you will know more about me as we go deeper in the course. So I'm a purpose coach as well, so you'll know more details about me. Um, and life and purpose coach. I do lot many things. Uh, Only technology training is just this is like a part-time thing. I have a full job. I lead a big machine learning engineering team for a large bank. Lot many things are there. So the teaching is my passion, and I try to use it. A PhD is a mechanism for utilizing the passion. All right, so excuse me. So thank you very much. Uh, Wonderful. We will discuss more things. We have to be keep updated ourselves. It's like latest trends are there. One thing is, if you are part of that kind of work, that your work is that you need to identify new technologies, new research areas, create new products, then that itself will drive you, right? So it's a part and parcel of your job. Now I'm trying to analyze, for example, in my day job now, I'm trying to analyze agentic AI memory management. Like, what does it mean for storing conversations, and to what extent we can store how do we involve PII data in conversation storing, all those things, which is quite a difficult topic. So that's what I'm researching on. Maybe after a few months, we might get a product on that, right? So that's how I keep myself updated. So I just want to show one more, I think, so this is the structure, right? So this is the structure of the course. I was kind of discussing in the past demo that we will start with Python for AI, and my sessions 99% we will not have any presentation. Okay. It will be going like this extempore mode. You ask questions, I will go and talk about it and so on and so forth, right? So it goes in an extempore mode. This is the structure of the course. We will be starting Python for AI, then we'll get into machine learning, generative AI, agentic AI, ML ops and LLM ops and cloud computing. Each area is having practical examples. Again, I will not waste time like Ashoka planted trees and in 1947 this happened. I will not talk about that. I will give clues like where to go and learn and all that stuff, but we will be doing hands-on so that if I spend like 1 hour, you need to, after the 1 hour, you need to have a clear idea that what is that we are going to cover. And this course is going to be very hands-on, guys. So I want you guys also to pack your bags. You'll be very, very active so that the learning is beneficial for you. So I'm quite sure that you're not here for a time pass, right? So you're like, okay, this today night I don't have anything to do. I don't have anything to watch on Netflix. So let me go and listen to Sitaram. That's not the case. So there is a real motive. There is a real reason for you guys to be here, staying here, listening to me. So I want urge you to that you to spend real quality time for the next 2 months, 2 to 2.5 months. Of course, there will be New Year's, there will be Sankrantis and all, where you'll have some holidays, but you'll spend around 2.5 months for the next couple of months for learning this entire stuff. Okay. So don't worry about any basic details. We'll be going to very, very basics. I'll talk about the basics. What do you have to install? What softwares you need require? How do you do the coding? All those things we will discuss right from next week onwards. So this week, probably you'll do a few more demos so that everybody gets an understanding of the style, the content delivery, the way I am delivering information and so on. And eventually we will get into the coding part. All right. So till then, take care, guys, and have a nice day. I'll talk to you tomorrow, same time, and have a nice day. Bye-bye.